Welcome to the AI Research Roundup. I'm Alex, and today we're looking at a paper from the Hugging Face trending list, published on the 20th of June, 2025 T, 18 hours, 23 minutes, and 48 seconds, 0.000Z. This paper, published just under 2 weeks ago, finds that some self-correction methods can actually make models worse, sometimes dropping performance by nearly 17%. The paper is titled, Aha Moment Revisited. Are vision language models truly capable of self-verification in inference-time scaling? And the reason why is fascinating. It seems these models struggle to robustly check their own work, creating a major gap between generating answers and verifying them. So to test this, the researchers used a specific verifier prompt. It basically tells the model, now you act as a judge, and asks it to pick the best answer from several options it generated earlier. This process is a key part of what's called best-of-n sampling, where the model creates multiple candidate answers and then tries to verify, or check, which one is the most reliable. The prompt is very direct, even specifying the output format, asking the model to choose a response and explain its reasoning. Now, this idea of a model checking its own work is often called an aha moment. To find these moments automatically, the researchers used this special aha search prompt. They didn't show this to the model being tested. Instead, they fed that model's reasoning into GPT-4o and asked it to act as a detective. It was instructed to look for beneficial behaviors like backtracking, which is just explicitly revising an approach after hitting a dead end, and verification, or checking its own work. This let them systematically count how often these aha moments really occurred. So after using that detective prompt, this table shows what they found. It measures the conditional accuracy, basically how often these aha moments actually helped. The first column shows the chance of a correct answer if an aha moment was detected in the reasoning. As you can see, the numbers are not great. The best model, VL Rethinker 7B, is only correct about 65% of the time. The second column is even more telling. It shows the chance that an aha moment actually corrected an initially wrong prediction. Those numbers are tiny, barely reaching 19%. This next table really drives that point home. It compares different ways of getting an answer, or decoding strategies, on the GeoQA dataset. We see methods like majority votes, where the model just picks the most common answer out of several tries, and chain of thought, where it reasons step by step. These consistently perform well. But look at the best-of-n columns, where the model tries to verify its own work. For some models, taking the image away during verification actually improves the score, which is wild. This suggests they aren't really using the visual information to check themselves. And we see this exact same pattern on another dataset, Math Vista, which includes math and reasoning problems. Again, the table compares best-of-n verification, both with and without the image, against the simpler majority votes method. For several models, like the R1VL series, the score is actually higher when the verifier can't see the image, but the most telling result is in the final column. Majority votes consistently outperforms the self-verification methods, often by a significant margin. This really highlights the generation verification gap. The models are simply better at generating answers than checking them. Alright, so to wrap things up, the key takeaway here is a major generation verification gap in current vision language models, which are AIs that process both images and text. They are simply much better at generating lots of answers than they are at checking them. And those supposed aha moments that come from a training method called reinforcement learning, well, they don't reliably improve accuracy. This research really calls for a new focus on building genuine, multimodal verification abilities into these models. That's all for the AI Research Roundup. Thanks for tuning in.